The brain-computer interface, BCI, is an exciting new technology that has the potential to revolutionize the way humans interact with machines. In its simplest form, a BCI is a device that reads and interprets signals from a user's brain and translates them into instructions for a computer or other device. This technology has the potential to improve the accuracy and speed of communication between humans and machines, allowing for more efficient and intuitive interactions. In order to create a better brain-computer interface, BCI, developers must first understand the underlying technology and the components that make up a BCI. At its core, a BCI is composed of two parts: the input device, which captures signals from the user's brain, and the output device, which interprets the signals and translates them into instructions for the computer. The input device is responsible for capturing and processing signals from the user's brain. This can be done using various types of sensors, such as electroencephalography, EEG, sensors, magnetoencephalography, MEG, sensors, or functional near-infrared spectroscopy, FNIRS, sensors. These sensors detect brain activity by measuring electrical or magnetic fields generated by neurons. The output device is responsible for interpreting the signals from the input device and translating them into instructions for the computer. This can be done using various types of software programs, such as logic programming languages. Logic programming languages, such as Prolog, are designed to solve complex problems by breaking them down into smaller, more manageable tasks. By using these types of programs, developers can create programs that interpret signals from the input device and translate them into instructions for the computer. In addition to the input and output devices, developers must also consider the user interface when creating a BCI. The user interface is what allows users to interact with the BCI and control its functions. This can be done through various types of input devices, such as keyboards, touch screens, or voice commands. The user interface should be intuitive and easy to use, so that users can interact with the BCI without having to learn complex commands or technical jargon. Once the user interface and the input and output devices have been implemented, developers must then consider the actual programming of the BCI. This involves writing code that translates the signals from the input device into instructions for the output device. One way to do this is to use a logic programming language, such as Prolog. Prolog is a powerful language that allows developers to create programs that interpret signals from the input device and translate them into instructions for the output device. Creating a better brain-computer interface, BCI, requires a combination of hardware and software components. Developers must understand the underlying technology and the components that make up a BCI, as well as the user interface and programming necessary to create a functional BCI. By using logic programming languages, such as Prolog, developers can create programs that interpret signals from the input device and translate them into instructions for the computer. With the right combination of hardware, software, and programming, developers can create a more efficient and intuitive brain-computer interface that can revolutionize the way humans interact with machines.